Welcome back, and we're going to look at my favorite derivative rule on Earth, and also the one that is most easily missed by students. So, like, have your uh, have your keen eye on the lookout for this rule. It is called the chain rule. Okay, you remember when we talked about the derivative of e to the x, it was defined as this, but I said actually we need to consider it like this. Well, that's actually the chain rule. And the idea here is that when you have a composite function, again, that's kind of a nesting of functions, so with a function within a function, we have to take the derivative in a different way. Okay, it's actually, according to the chain rule, what we have to do is kind of take the derivative of the outer function times the derivative of the inner function. And so what I think of when I think of the chain rule is, imagine there are vertical bars here that I think of as like the differentiation bars. Okay, they have to squeeze through the function until they meet each other. Okay, so you have to first, so the bars are going to hit f of x first, and it's parentheses. So you have to differentiate f first. Okay, after you differentiate f, then you have to move in and differentiate g. And then when you differentiate g, you need to differentiate x. And so you get something where it's f of x times g of x, or f of x, or f prime of g of x times g prime of x. Note that as when you differentiate those outer functions, you leave the inner function alone. Okay, so for example, this one, when you imagine those vertical bars here that are differentiation bars, when you look at the derivative, it should be so you have to differentiate sine, which we know is cosine now, and then you would leave the 3x alone, and then you would multiply by the derivative, and then the vertical differentiation bars now move inside, so I'm going to move them inside and multiply times 3. Okay, now the vertical bars work for me. Some people don't really get it, and I get that too. Some people really understand the idea of composite functions. So if that is you, then here's how you can view the composite functions. I'm going to do these by color. So the outer function here would be the cube function. So that would be the first thing that you'd have to differentiate, is effectively x cubed. Then inside of that, we have the function 1 minus 2t. So then you'd have to differentiate that. Consequently, when you look at the overall derivative, g prime of t, you would have, okay, so now we have 3 times x squared, right? Or just where x is now the 1 minus 2t. And then, according to the chain rule, you need to multiply by the derivative of a 1 minus 2t, which is minus 2. Okay? So that's another way to view it. Maybe the colors work for you, maybe they don't, maybe those vertical bars work for you, maybe they don't. If you have a different way of thinking about the chain rule, I'm all ears. Here, again, if you think about this as composite functions, oops, this is h. Your two functions here are e, and then tangent of p. Actually, e to the x and then tangent of p. So then, when we differentiate this, we get e to the x, or x is just tangent p in this case, and then times, now the derivative of tangent p is secant squared p. Okay, so those are some examples with chain rule. Be on the lookout for these, and also know that we can chain chains. So you can have multiple chain rules happen for a single function. We'll see that in the next video.